राइट, पेट्रोल या जिसे हम कॉमनली गैस या गैसोलीन भी कहते हैं, डीजल, ये रोड ट्रांसपोर्ट में यूज होते हैं। इनका सबसे सल्फर हम पहले ही रिफाइन कर चुके होते हैं। सल्फर डाइऑक्साइड एक सीरियस प्रॉब्लम नहीं है मोटर व्हीकल्स के लिए, लेकिन बाकी कंटेंट्स एग्जॉस्ट व्हीकल फ्यूम्स के वो प्रॉब्लम्स कॉज कर सकते हैं। What are the other contents that can cause problems? Let's talk about those. To begin with, nitrogen dioxide is an example. It is still produced. How is it produced? Now, these lines are pretty important and have been a part of past papers. The high temperature and pressure, all right, inside, do mention and pressure on top of it, inside the engine cylinder causes nitrogen and oxygen in the air to react together. And this forms this. Actually, to be honest, the reactions move like this. ठीक है, heat and pressure, इसके ऊपर दोनों आप एरो के ऊपर लिखें, all right, and this 2NO further reacts with oxygen and forms 2NO2, all right, again heat and pressure. These are the stepwise equations. Either you write these two equations or you write a single one, it's the same. ये दो लिखना इसलिए होता है ताकि आपको समझ आ जाए how it is forming. You can write a single equation and just get it over with. Make sense?
Yes.
Okay. Nitrogen dioxide we have discussed previously. How is nitrogen dioxide a problem? Yeah, there. Okay, remember nitrogen dioxide, and I'm underlining this, causes acid rain. Don't forget, we discussed previously that NO2 in the presence of oxygen and in the presence of water from the raindrops can be converted into HNO3. HNO3 is an acid. It falls in the form of acid rain on the planet, and wherever it falls, it causes a problem. Be it a building, be it a tree, be it a human, be it an animal, be it a marine environment, a lake, a water body, anything like that. All right?
Yes, sir.
This is not the only content of the vehicle exhaust that causes a problem. Since there is lack of oxygen in the enclosed space of the engine, the fuel does not usually burn completely. So there is what? There is incomplete combustion. And I hope you remember incomplete combustion from chapter number 10 of the same book. Do you remember that?
Yes.
Incomplete combustion is when any hydrocarbon, let's say CH4, although we're talking about fuel, we can take the example of C8H20, but C8H18, sorry, but it would be a much difficult example. So I'm going to go with an easier one. Reacts with oxygen and produces, instead of carbon dioxide, produces carbon monoxide and water. You may balance the equation later, but the point being carbon monoxide formation, which is actually a problem. Okay, so NO2 is a problem, and the problem of NO2 is mentioned over here. Carbon monoxide is a problem, and the problem with carbon monoxide is mentioned over here. Now, carbon monoxide is a highly toxic gas. It combines with hemoglobin in the blood and stops it from carrying oxygen because it makes a very strong bond with hemoglobin. I am hopeful that you are familiar with the word hemoglobin, right?
Yes, sir.
It is commonly measured in blood tests during blood tests for humans. And the measurement of hemoglobin gives us the idea that how much of your body can work well with oxygen. More hemoglobin means your body is good and it can work well with oxygen. Less hemoglobin means your body is going to carry less amount of oxygen than what is actually required, right? Remember, hemoglobin is the part because of which we have the red color of the red blood cell, and because of which the whole blood is red. I hope you have also learned the names such as red blood cells and hemoglobin from
Yes,
biology,
sir.
right?
Mm.
Good, good. So when carbon monoxide reacts with hemoglobin, it makes a stronger bond than what oxygen can. and hemoglobin is not capable of bonding with oxygen. So what happens is slowly that you run short of hemoglobin molecules that can bond with oxygen. So with small amounts of carbon monoxide, it may cause dizziness for a longer duration, for a more duration of time. It may cause a headache. Later on, it may turn you unconscious. And finally, it can go up till death if you stay in the same environment for a longer duration of time. Usually, in a room filled with carbon monoxide, you can last as long as 30 minutes.
Oh, oh,
So, what do we say? Never burn anything in an enclosed space for a longer duration of time. So, people who are using gas heaters, people who are burning stuff in enclosed spaces, enclosed rooms, often face the same problem. All
mm,
right?
okay, sir.
Good. Great. All right. This is not only the problem. Let's move on forward and see what more problems can we face from the exhaust fumes. Okay. Now, another pollution problem arises from motor vehicles and it is caused by tetraethyl lead in petrol. Now, let me first explain what is tetraethyl lead. Now, the word tetra means four. Ethyl is actually a branch by the formula of C2H5, so that means 4C2H5, and lead is Bb, a weak metal. In this whole component is used in petrol that is known as leaded petrol. Now, I hope you might have studied the same name back in chapter number 11, where they explain that
Yes,
this component was used as an anti-knocking agent back in the previous times. We don't use it anymore. There's a huge ban on this substance around the world, but previously it was used as an anti-knocking agent. Right? Knocking is the sound produced while we are trying to turn on our car, and while using the ignition, this was the sound produced by the engine. And we later on understood that production of this sound means a lesser engine life. So we started coming up with ways so that we can reduce the sound. Apart from the fact that the sound is irritating, it also harms the engine. So we started using this component, and the petrol started begin as leaded petrol. Now, what are the disadvantages? Let's study the rest. Burning this type of petrol releases the toxic metal lead into the environment. The uses of lead in the petrol has decreased significantly over the last 20 years. In 2011, United Nations announced the successful worldwide phasing out of leaded petrol for road vehicles. So now you see unleaded petrol almost everywhere on the planet. There are only a handful of countries where it is still available, unfortunately, Pakistan being one of them. Unfortunately, just a few areas, but we are still trying to phase it out. And that's actually a really good step. Now, let's talk about the dangers of these pollutants. We've studied about nitrogen dioxide that it can cause acid rain. Apart from that fact, it may combine with other gases in very hot weather and cause smog, photochemical smog. Now, I hope you are familiar with this word. Smog is actually a combination of two words, smoke plus fog. Since fog is capable of trapping smoke, that is usually caused due to traffic, due to industry, due to burning of fossil fuels, and then fog becomes dangerous. Now, this usually happens photochemically due to the presence of sun. It also contains low level ozone. It is likely to cause breathing problems in humans, and it is a really bad news for the people with asthma. Asthma is a respiratory disease. I hope you might have heard the name before, right?
mm,
We've already studied carbon monoxide in complete detail. Let's talk about lead. Lead is neurotoxic. It's actually not as neurotoxic as it is to children, it's not neurotoxic to adults, not at least in small amounts. For children, it may cause problems. Since children's bodies are underdeveloped and the bodies do not yet know how to get rid of even small amounts of lead, they call learning difficulties. One of the most common learning difficulties is that the child starts forgetting stuff. And what do we do with that child? We start beating the child. तुम्हें याद नहीं रहता, तुम पढ़ के भूल जाते हो. And this may even be a simple problem caused by breathing again and again in a area that is full of traffic and traffic smoke. बड़े को उसमें कुछ नहीं होगा, बच्चे को हो जाएगा, इवन छोटी क्वांटिटीज में भी हो जाएगा. ठीक है? Previously, we regarded that as dumbness in children. Later on, we understood it's a neurotoxic and it's actually becoming a problem. So the body of a child does not know how to get rid of lead. So small amounts can build up to dangerous levels over time. And the same thing may happen to an adult, not just to a child. So for an adult, the body knows how to get rid of very small amounts of lead, but the buildup may be problematic for any of them, be it an adult or a child. All right. So these are the problems related to almost every one of them. Carbon monoxide has just one problem since it's toxic. There are two problems related to nitrogen dioxide, smog, and acid rain. There are two problems related to lead. There is actually just one problem, and that's neurotoxic and causes learning difficulties that is associated with lead. So for which one, the one you have two problems, try remembering both of them. For one which have only one problem is mentioned or one disadvantage is mentioned, try remembering that one, since these 3 points have been a part of past papers. Right? Now, solution to these problems. Something you might have already discussed as a part of chapter 7 or as a part of chapter 9 and 11. Also in chapter 10, actually. So, catalytic converters. Catalytic converters are a good solution, a pretty good one at that, and they are attached to the exhaust systems of cars and even mentioned on the rear view mirror of the car. Rear mirror, rear windshield of the car, not the rear view mirror, sorry, rear windshield of the car. Now, they convert carbon monoxide and nitrogen dioxide into carbon dioxide and nitrogen. And actually, carbon monoxide is toxic, nitrogen dioxide is a problematic gas. Carbon dioxide and nitrogen, however, are less harmful in comparison. Unfortunately, if there is lead in the petrol being used, the catalyst becomes poisoned and will not work any longer. This means you need to use unleaded petrol for the catalytic converters to work. And I don't know whether you remember it or not from chapter number 7. So I'm going to just scroll it over there. To find out the exact place where they're written. Not just that, you would find a set of 3 to 4 equations over there to go with it. And from there on onwards, you'd see. Now, that's the part of catalytic converters. This is page number 188 of the book. It discusses that carbon monoxide, nitrogen monoxide, or nitrogen dioxide, unburnt hydrocarbons, there are problems. Now, in order to work with these problems, we have this honeycomb kind of structure made up of different alloys of platinum, iridium, palladium, and stuff like that, mostly transition elements. What we do is that we react with carbon monoxide with oxygen to convert it into carbon dioxide, which is a very harmless gas as in comparison to carbon monoxide. Since carbon monoxide is toxic, we may react nitrogen monoxide and carbon monoxide together to produce nitrogen and carbon dioxide, both being harmless gases. Lastly, we may convert nitrogen monoxide back into nitrogen and oxygen gases, which are a part of the air, our atmosphere. And something he has written in a word equation, since there can be many possible equations for that. Hydrocarbons plus oxygen give us carbon dioxide and water. Both the things are already present as a part of the atmosphere. Now, you would notice that this removes all of the problems. Not just that, he's talking about that a honeycomb structure actually gives rhodium and platinum a huge surface area for the reaction to occur. He's also discussing that it has to be used with unleaded petrol, If there is the presence of lead, it would poison the catalyst. How? It would clog the pores. Since being a heavy metal, it would clog the pores, and then the catalyst would eventually stop working. All right. So this is the place where they
Yes,
discuss and explain every possible equation for catalytic converters. Catalytic converters have really been an important question in past 5 years. So you'll find a lot of questions in the recent years for this one. Also, they have been asking you to write the equations, so you should be familiar with all four of these equations. Be it chemical equations or word equations, that does not matter. You should be able to reproduce these in exams. So make sure you mark them, make sure memorize them.
okay, sir.
Clear enough? I'm correlating all the pages of the book wherever the information is given. So I'm going to jump up to another chapter. This is chapter number 11. And here, blending gasoline, they're talking about lead at the bottom of the page. This is page number 280. They're talking about tetraethyl lead. They're talking about knocking and anti-knocking agents that I was discussing earlier. Low levels of lead, how it can cause brain damage in young children, how we should be using unleaded petrol for our cars, and how catalytic converters work, right? So all of the stuff is also given over here. So you should be able to
Yes,
link all three of these in one place. Remember, the pieces of information are almost same in all three places, discussing the same fact, but in different ways. They are discussing the point of tetraethyl lead being a knocking or anti-knocking agent and the problems of lead if it becomes a part of exhaust fumes. In catalytic converter, we discussed the working of catalytic converter. We also gave you a set of equations which we never gave you in any other chapter. And in chapter number 1, we were simply discussing the problems of lead if it was a part of exhaust fumes. Clear enough?
yes,
And
sir.
then on the next page of the same chapter, chapter 1, where we were at, we have a big diagram explaining how harmful or less harmful gases in comparison are released out of the exhaust fumes if and if not we are using a catalytic converter. Comparison. Clear enough?
Yes, sir.
Any questions before we move forward?
No, sir.
Okay. So moving on, we have a very good diagram that is going to explain a combination of all of the things we have been studying. Okay, and what we are supposed to study next too. So if you take a look, actually oxides of nitrogen, NOx, which means NO and NO2 both, the unburnt hydrocarbons, which we have been uh, symbolizing with HC, hydro and carbon, right? Carbon monoxide, CO, they all become a part of photochemical smog, the combination of smoke and fog I was discussing previously. If we also add one more component to it, sulfur dioxide, we get all of these a contribution towards acid rain. If we add two more gases to it, carbon dioxide and methane, we get all of the contributing factors to global warming. Global warming is something which we are supposed to study yet, but we have studied acid rain, photochemical smog, and the effects of these four already. So we are left to study the effect of these two and global warming. Make sense so far?
Yes, sir.
So far, so good?
Mm.
If not good, it should be at least okay. All right, continuing. Okay, so let's explain what global warming is. Let's explain what greenhouse is or greenhouse effect is, all of that. Before we move on with anything like this or these diagrams, I'm going to explain what a greenhouse is. So Jahrukh is going to draw with his poor drawing skills a small house. Let's suppose this is a house. This is the door of the house and the actual house. Let's suppose we have some plants in this house. Now, greenhouses are the houses that are commonly used in colder parts of the world. In colder parts of the world, the temperature is so low that it is almost impossible to grow any kind of crops. Now, at this kind of temperature, it's very difficult to grow crops. We need to increase this range to a little bit more, up till 25 degrees centigrade or 30 degrees centigrade, in order to be able to grow crops well. Now, what do? We make some glass houses, we line them from the inside with plastic sheets, right? And we grow crops in there. We used to call these houses as greenhouses, and this there were green crops inside, right? Back in the day.
Hmm.
We're talking about a good amount of time earlier, a few decades earlier, all right? So we used to call those greenhouses. The point of making this house of glass and using plastic was that the sunlight was able to come in, since it was made up of glass, but it wasn't able to go back, and the heat was trapped along with the light in this house. The heat and light causes the temperature to increase from this range up to this range. So the crops were able to thrive, although there was snow outside, but inside the greenhouse, the crops were able to thrive and grow, right? So we used to call that a greenhouse, all right?
Okay.
The greenhouse effect was the effect by which the sunlight was able to come in due to the whole house being made of glass, and plastic was acting as an insulator on the inside, and it never let the heat and the light go out and trapped it inside for the temperature to increase to a value so that the crops would be able to grow inside the house. We used to call that as a greenhouse effect. Okay, but that concerns only one greenhouse. We are going to talk about global warming. Global warming is actually the increase in average temperature of Earth. And we use the same greenhouse effect for the entire planet. Now, you'd notice I'm going to use the entire planet as a greenhouse. Now, our planet is filled with plants, so it's already green. Now, the atmosphere around the planet is this much, and you'll see this whole line, and this light blue area, this whole area, is the atmosphere of the planet, which is filled with gases, different gases such as nitrogen, oxygen, water vapors, carbon dioxide, all of these gases, right? Now, some of these gases are contributing towards the greenhouse effect. They're acting like those plastic. They're letting the energy radiated by sun to come in, but they're not letting all of the energy to be radiated back. They're actually trying to trap some of the energy inside. And we call this effect as greenhouse effect, right? Since the same effect is applicable to the entire planet, which was applicable to small, a poorly drawn greenhouse by Sir Jahrukh, right?
Hmm.
Okay, so we started calling these gases as greenhouse gases, since they are acting as a major role for the greenhouse effect. And because of these gases, the average temperature of the planet increased in last 100 years, or you can say maybe 200 years, from 13.5 degrees centigrade as an average temperature for the whole planet, all the way to 14.2 degrees centigrade. Now, this is an average temperature. Not the entire Earth has the same temperature. You know, around the equator, we have the warmer areas. Around the polar regions, we have the colder regions. आपको पता होगा पोल्स के आसपास, इन जगहों के आसपास आर्टिक हो गया, अंटार्कटिक हो गया, बिल्कुल स्नो से भरे हुए इलाके हैं. और अराउंड द इक्वेटर हमारे पास, खासतौर पे सऊदी अरेबिया इक्वेटर पे लाया करता है. So you have the harshest of summer, along with the rest of the
Yes,
Middle
yes.
East, not just you. ठीक है? So Earth has different temperature in different regions, but for the entire planet, we have an average temperature value. All right. This average temperature has increased in the past 200 years by a very small value. Now, this seems to be a very small value, but this value has triggered a lot of factors, which we're going to study in the next page. Now, burning fossil fuels, forest fires, industry, human activity are producing various greenhouse gases. And as the amount of these gases are increasing more and more of the sun energy is trapped, and the Earth is warming up as a planet. Make sense?
जी सर.
If all of this makes sense, then can we move on to the next page?
Yes sir.
Okay. So now keep the two names of the gases in your mind, carbon dioxide and methane being a very big contributor towards global warming. Okay. So some of the problems that global warming is causing, the average temperature of the Earth has increased by just 0.7 degrees centigrade. And what has that caused? Glaciers and polar ice is melting. Pakistan has a flood right now because of this. ठीक है? दुनिया में सबसे ज्यादा पोलर रीजन्स को छोड़कर, दोनों पोल्स को छोड़कर सबसे ज्यादा ग्लेशियर्स किस कंट्री में? पाकिस्तान में. ठीक है? तो सबसे ज्यादा मेल्टिंग कहां पर हुई? पाकिस्तान में. एंड Pakistan has faced major floods in past 20 years, more than any country on the planet. Why? We have most glaciers. We have thousands of glaciers, and the biggest one at that. ठीक? This will cause in a rise in sea level. इसकी वजह से sea level भी rise हो जाएगा और बहुत low lying land flood हो जाएगी. Up to 2030, ठीक है, 30 more islands जो होंगे वो जमीन के नीचे चले जाएंगे, पानी के नीचे चले जाएंगे, सॉरी, जमीन के नीचे नहीं, पानी के नीचे चले जाएंगे, just because sea level rise कर जाएगा. And all of those islands are currently inhabited. वहां पे बाकायदा शहर हैं, पूरे पूरे कंट्रीज हैं, और वो पानी के नीचे चले जाएंगे in next 5 to 8 years अगर हमने ग्लोबल वार्मिंग पे कंट्रोल ना किया. The surface temperature of the earth will increase, deserts will spread जो कि अभी भी हो रहे हैं, and millions of people will have less water. Half of the Africa. आज भी अफ्रीका में थर्स्ट की वजह से बच्चे और खवातीन मरते हैं. मर्द भी मरते हैं, ऐसी बात नहीं है, एल्डर्स स्पेसिफिकली. ठीक है, आपको यकीन नहीं आएगा. We have so much water, and in other part of the planet there are people who die of thirst. They don't get enough water. Now severe weather events will increase in frequency. और आपने देखा होगा जब से आप बड़े हो रहे हैं, आपके पास सोशल मीडिया और न्यूज़पेपर्स भरे होते हैं ओवर द इंटरनेट अबाउट हरिकेन्स एंड अबाउट फ्लडिंग. ठीक है, बहुत कॉमन है. name any country in the world which have these events, और आप मुख्तलिफ hurricanes और floods के नाम ले देंगे. Right now we are facing one. We're sitting at the center of one. ठीक है? Now, in some areas it may become easier to grow food crops, but in other areas it would certainly become more difficult. और जहां पर difficult होगा, उन्हें easier वाले areas से purchase करने पड़ेंगे और वो मजबूर हो जाएंगे. And there comes the monopoly then. जिसके पास होता है वो फिर कहता है मैं तो प्रॉफिट अर्न करूंगा, मैं तो जेबें भरूंगा. ठीक है, एंड देन द होल मोनोपोली थिंग स्टार्ट्स. सो अ लॉट ऑफ प्रॉब्लम्स, a lot of political, financial, and economic problems are related to a simple phenomenon like global warming. This may seem like a simple phenomenon, but the problems are limitless. ठीक है, अब प्रॉब्लम इसमें है क्या? दो गैसेस, कार्बन डाइऑक्साइड एंड मेथेन. मैंने आपको कहा था ये याद रखना है. नाउ मेथेन इज 20 टाइम्स मोर इफेक्टिव एट स्टॉपिंग हीट एस्केपिंग देन कार्बन डाइऑक्साइड इज. कार्बन डाइऑक्साइड तो हम भी रेस्पिरेशन के थ्रू एक्सहेल कर रहे हैं, प्लांट्स उन्हें इनहेल करते हैं फॉर फोटोसिंथेसिस, लेकिन चूंकि हम बर्न कर रहे हैं ज्यादा से ज्यादा फ्यूल और कट डाउन कर रहे हैं फॉरेस्ट को, हम जब तक फर्दर मोर ट्रीज प्लांट नहीं करेंगे ये हेल्प नहीं करेगा. ठीक है, लेकिन हमें सिर्फ ट्रीज प्लांट करने से कुछ नहीं होगा, हमें फॉसिल फ्यूल कंजम्पशन भी कम करनी पड़ेगी. ठीक.
जी सर.
मेथेन, मेथेन एनिमल्स प्रोड्यूस करते हैं. लिस्ट के टॉप पे काउस आती हैं. दुनिया का 20% मेथेन काउस प्रोड्यूस कर रही है. टर्माइट्स, टर्माइट्स वो छोटे छोटे कीड़े होते हैं जो वुड को बड़े शौक से खाते हैं और वुड खराब कर देते हैं. ये भी बहुत ज्यादा प्रोड्यूस करते हैं मेथेन. Bacteria produces a lot of methane when they are going with the decay process. कोई भी dead organic matter पड़ा हो, fallen leaves हो, plant के parts हो, कोई dead animal body हो, bacteria से heat up कर रहे हो, ये करते हैं. राइस की फील्ड्स के अंदर, ये राइस पैडी फील्ड्स हैं. ठीक है, राइस प्रोडक्शन में बहुत ज्यादा हमारे पास मेथेन प्रोड्यूस होती है. लैंडफिल साइट्स बहुत ज्यादा मेथेन प्रोड्यूस करती हैं. ठीक है, ट्रीटमेंट ऑफ ऑर्गेनिक वेस्ट से हम मेथेन को कलेक्ट कर सकते हैं और उसे यूज कर सकते हैं. Instead of releasing methane to the planet and cause it to increase further global warming, हम क्या कर सकते हैं कि हम उस methane को collect करें और उसे अपने लिए burn करें, carbon dioxide में convert कर लें. Methane is 20 times more effective in causing the problem. So अगर methane को हम save करते हैं और उसे convert कर लेते हैं carbon dioxide में, at least we're reducing that 20 times more effect, if not anything else. Make sense?
Yes, sir.
Good, great. And here we finalize the atmosphere part. So atmosphere and air pollution is complete. So 1.3 season rivers. Now let's go with this diagram first. If 100% of the water present on the planet, 97.5% roughly are oceans, salty water. We cannot use it for any of our daily water purposes. Okay? The rest of 2.59% is fresh water, but out of that, roughly 2% is ice caps and glaciers. Again, that can't be used. What are we left with? Around 0.6% of groundwater. 0.6% of the groundwater is the water that we are using for our freshwater sources, out of which some of it are rivers, some is atmospheric water vapor, some is biota, most of them are lakes, some is soil moisture, so on and so forth. This is our readily accessible freshwater source. So if the entire oceans were 100 liters of water, only 3 liters is the one that is fresh water, and only 3 cubic centimeter, which is not even a teaspoonful, let me tell you, it hardly can be counted up to 6 drops of water, is the one that we can consume. Out of 100 liters, is 6 drops of water roughly are the ones that we can consume. That is very less fresh water. So fresh water is actually not a commodity that we can waste. But if we talk about our daily routine, we are wasting a lot of fresh water every day, right? Because of which we are coming up with water pollution related problems. Now let's discuss about water problems. Since we have very less fresh water available, so many parts of the planet are using water treatment for their purposes. The top among those countries, Saudi Arabia. Even the book says the name of Saudi Arabia. You can see it right over here, right? Okay, so let's talk about that.
Yes,
Water from rivers, lakes, and from underground contain dissolved salts, solid particles, and bacteria, which are not good for health. So we need to treat that water, purify that water, and convert that water into drinkable water. All right. So at its simplest, water treatment involves filtering of water. If we filter water, we will remove all solid particles. We may add chlorine to kill any bacteria that can cause disease, but it is also an overrated part of the process. We explain it at the level of books, but we have much better ways to now kill bacteria. Okay, so let's talk about a modern water treatment process. Now, this part is explained in figure 1.15, so we're going to jump for the first paragraph to figure 1.15 and explain it from there. This one. Let's explain the parts. Make sure you have the book open and make sure you can write the things that I'm going to ask you to write on book. Are you ready with the book and a pencil?
yes, sir.
Good, great. So from a river source, which are a main source of water, in case of river, it's actually the oceans. Riyadh and Jeddah have, specifically Jeddah has a big water desalination plant. And most of the process parts that are written over here are already occurring on that plant in Jeddah. Okay? But you're not in Jeddah, you're in Riyadh, right?
Yes,
Okay. Riyadh also has a desalination plant, not as big as Jeddah, but it has one. Okay. So first of all, we have screens. What are screens? Screens actually strain the floating rubbish. Screens are actually a bigger version of the strainers we commonly use at home for the straining of tea powder from the tea material. I hope you have enjoyed tea at home, right?
yes, sir.
And I hope you understand what a strainer is, which is usually used to
Yes,
separate the tea powder from the liquid. so that you can easily drink the liquid, right? So I hope you've seen the
Yes.
strainer. It's a mesh like this one, a network of wires, small wires, which can stop all the tea powder particles and let the liquid flow through it, right?
Yes, sir.
So the similar thing at a larger scale is known as screen. Now it is going to make sure that no rubbish enters the entire plant. Now then we have pump, which pumps the water to the next step, that is storage reservoir. We treat it with a small amount of ozone to disinfect the water. We're going to use ozone, the formula of which is O3, and it's a very good oxidizing agent. All right. Now, oxidizing agents are explained very well in chapter 4 of the same book. These are the agents which can give oxygen to any of their reactant materials. कोई भी चीज इसके साथ react कर रही है, उसे oxygen provide करेंगे, and then that oxygen can react with it, change the whole structure. ये water को disinfect करने के लिए बहुत बेहतर है. Also, it turns the water odorless. इसका bad odor remove करता है. Odorless लिखने की बजाय it's a better idea if we write the phrase removes bad odor. ठीक है, कि वो वाटर के अंदर गंदी स्मेल भी हो सकती है, सिंस वो ऐसी सोर्स से आ सक रहा होता है जो साफ होना जरूरी नहीं है, राइट? Disinfect means it
Yes.
may also kill bacteria. So actually it is doing a lot of things at the same time, since it's capable of doing all of these. Okay, from there on onwards we also have some more steps. You'd see that next one is precipitators. I'm not going to explain what precipitators are, but they clear solid particles by converting them into precipitates. Now, even if you're not familiar about precipitators, you're familiar with the term precipitates. Precipitates is the formation, sudden formation of solid that we discussed in 5th chapter of the same book. So precipitators actually remove those solid particles. Then we have rapid gravity sand filters. Again, they filter out all the solid particles. We're consistently filtering out the solid particles, bigger ones over here and the smaller ones over here. Make sense?
जी sir.
Why? Because the smaller ones usually pass the screens. But then precipitators and rapid gravity sand filters are able to remove them. Then we get to the main ozone pumps. Here we don't use a small amount of ozone. Here we use a main dose of ozone. It breaks down any pesticides, germicides, any of those kind of chemical sprays and other materials as well. It actually breaks down any chemicals present in the system. Okay. Then we have activated carbon granules. It absorbs some of the chemicals and odor. Please add and odor to it. Means it removes any bad odor. Then we have micro strainers again. So we have screens, and then we have smaller screens, and then we have micro screens. So we want to make sure that we can remove the big particles, then the small ones, and then the very small ones with the help of micro strainers. As the name suggests, it is micro strainers, 10 raised to power minus 6 meter based particles, micro. Right? Makes sense?
Okay.
And then we
Yes.
use chlorine. The purpose of chlorine is to disinfect water, means kill most of the bacteria. Right? Sometimes Cambridge thinks that kill is not a better word to use, so we use the word disinfect itself. So try not to use the word kill.
Okay,
Cambridge
sir.
suggests that this kind of word do not leave a good impression on children. So let's not use these kinds of bad words. Let's use the word disinfect. Because if bacteria is present, that is infected water. Removing bacteria means water is disinfected. Hence, I would suggest not to use the word kill and use the word disinfect.
Okay,
Then you
sir.
have clean water. We put it on a surface reservoir and that reaches the taps. So you get pure good drinking water through the taps. That's why we ask you to use water carefully. Conserve water. Do not waste water. since the water that is getting to you is going through a lot of process, a process for which everyone is paying the price. Anyone or everyone who's using it is actually paying the price. And
Yes,
actually,
sir.
this affects the whole planet, not just you. So, do you get the point how we treat water to make it drinkable from a
Yes, sir.
source where it was not drinkable? All right. So, let's get back to the original page if the whole diagram is clear to you. So, getting back to it, the water is then pure. If the water is not pure, it may consist some dissolved solids, calcium salts, that can aid health, but there are some fertilizers and other particles that can also be harmful, that can cause health problems. All right, that's why this treatment is important. In some parts of the world, seawater is made drinkable by desalination. Desalination means to take the salt out. This can be done by distillation or forcing the water through special membranes using high pressure. The process is known as reverse osmosis. However, desalination is very important for countries like Saudi Arabia, which is actually using ocean water, and by desalination, they are removing the salt out of it and then making the water drinkable. Remember, ocean water has a lot of salt. Desalination means that you need to take the salt out. They usually do it with the help of distillation in Saudi Arabia, and then they add minerals to it so that by desalination they would get distilled water, a term we commonly use in lab, right, or desalinated water, and then they add minerals to it, the minerals that should be a part of it, and that's how we get mineral water. All right, makes sense? You might not need to
Yeah.
note it down, just understand it. Okay,
Okay.
why are we quoting this one? Because it has very less water and it is using ocean water for its purpose. That's why you have cheaper coke prices and higher or
Mhm.
expensive water prices in comparison. And that's
Yeah.
actually as a quoted as a true example around the planet,
Mhm.
right? Moving on. Water supply is very important in our homes. We are using a lot of it. We are using water in industry as a solvent to cool down reactions, to transfer heat from one part of factory to another. All right. This is the industrial use of water. What is the domestic use of water? In domestic, there are many uses of water. And you'd notice out of every 100 decimeter cube, the drinking use is very small as compared to the cleaning use. This is all cleaning use. That's a big one.
Yeah.
And that's a small use as compared to drinking and cooking use. Right? So we're using more of the water for our cleaning purposes than we are using it for drinking purposes. So that's why we ask people and especially children to be very careful about wasting water while cleaning up stuff, while cleaning yourself or your clothes or whatever that is. Right?
Yes.
Okay, pollution water supply. First and foremost, nitrate fertilizers. They're a problem. We use fertilizers in the soil, but they often are washed into streams and rivers from the farmland. These nitrates are not removed by water treatment, can cause health problems for old people and for young children. They also cause waterways to become overloaded with nutrients, causing plant and algal growth. Since nitrate can be used by algae, and I hope you're familiar with algae from biology, so nitrates are the very good nutrients for plants, and you would see that green algae growing all over the place if they have that kind of nutrients. All right. Moving on,
Yeah.
industry sometimes discharges toxic and harmful substances into rivers that should be completely banned. And in sophisticated parts of the world, it is banned and checked. Untreated
Mhm.
sewage and other animal waste can be released into rivers, especially in the areas where there are new sewers. India being one of the topmost country in this kind of problem. Release of untreated sewage into rivers can lower oxygen levels by chemical reaction because that oxygen will then be used by bacteria since they love to eat sewage. right? And can cause the spread of harmful bacteria since it would grow, and this can increase the disease risk of disease. Okay. The use of water for cooling by industry can result in warm water being discharged into rivers. Warm water dissolves less oxygen than cold water, so animals living in water, fish, may be left with insufficient oxygen. That can really help the marine atmosphere, the marine animals, the marine plants, all of them. All
Okay,
right.
sir.
So
Yeah.
this is water's portion. We're only left with Earth's crust, a little bit of it, and hydrogen as a fuel. Why not we keep it for next sitting? And in the next sitting, we'll finish up the chapter.